Hi, and welcome to this video on a review of adding and subtracting polynomials. And the title of this presentation is It All Adds Up. This whole presentation will be about combining like terms, adding and subtracting polynomial expressions, and combining them all together. It would benefit the student to understand these following vocabulary terms, all 8 of them, given the topics that we're going to cover. So pausing the video now to look up the definitions to all of these vocabulary terms would be a great exercise before you continued. So to start off with this presentation, we're going to look at comparing adding and subtracting polynomials to the idea of just adding and subtracting numbers by themselves. So to start with, we consider this quick addition problem that 132 is equal to 100 plus 30 plus 2. And we can compare 132 to the polynomial expression x squared plus 3x plus 2. And you can see that the hundreds place, the 100 went with the x squared, the tens place went with the x term, and the 2 represents, in the ones place, represents the 2 down here as well. And you can see it's separated all like as you see right there. So if we were to look at number 2 and write out a polynomial, well, we have a 2 in the thousands place, a 6 in the hundreds place, a 7 in the tens place, and a 5 in the ones place. So if I wanted to write out for that, well, the 6 kind of compares to the 100 here. So I know I have a 6x squared term. I have a 7 in the tens place, like the 30 before. So that would mean that I have a 7x as a term. And then I have a 5 on the end, so I know there's a 5. But then we have an extra 2 on the front. So if I wanted to use that 2, I would have to make that into what would be above x squared, which we know as x cubed. And because it's a 2, our coefficient, the number attached to the variable in front, would have to end up being a 2. So that would go with the 2,675 that we see down there at the bottom. So now we are going to look through this addition problem of 132 plus 451 equals 583. And that is vertical addition. How you do addition, how you choose to do it for any given problem is totally okay. The main point would be, can you show your work and show to your reader that you know what you're doing? And so let's add these two together if they were polynomials. So the top polynomial, the 132, would end up being 1x squared, and the 1 in front is not always necessary, but we'll keep it there for now. And then we have a 3x, and then a plus 2 on the end. And that is for that first number. So let's change our color, and then we'll do the 451. So now we have 4x squared for the hundreds place, plus 5x, plus a 1. And now that we've kind of wrote that out, well, we can do that same bar, and we can have the addition sign. And if we have all these like terms, remember, like terms are anything that have the same variables but the same exponent or power above those same variable letters. And so now we're going to add these two x squareds together. Well, we already know the answer. Well, it's 5x squared, just like how 1 plus 4 is 5. 1x plus 4x squared is also 5x squared. And then we have an 8x, and we have a 3 as well. And that matches the 583. So we can see in answering number 4, how does adding polynomials compare to adding whole numbers? Essentially is exactly the same. You add numbers in the hundreds place together because they're both hundreds, and you add x squareds together because those are also alike in almost the exact same way. So let's keep moving forward. So we're going to kind of do some practice here with 4 different functions. You'll notice that each of these functions have a letter in front like f, g, h, and k. And then you have the x in parentheses. Remember, that's function notation. So for instance, you would read this second one as g of x is equal to 2x minus 1. Important that when it says g of x, well, that's the same thing as just y. But you can't have y equals for 4 different equations because they're not the same. You need a different notation, a different letter for each of the 4 different equations. So we want to do some practice problems here where we're going to add h and k, which we're going to add h and k right over here. So we can kind of show our work a little bit. We're doing 2x squared plus 5x minus 12. And then we're going to add to that negative, not negative 2, negative 1x squared, or just negative x squared. And we're going to add a negative 3x and a positive 4. So let's use that line to our advantage and write it out as plus. And so we do 2 plus negative 1 is equal to 1x. Oh, this should have a square next to it. 1x squared. And then we have 5 plus negative 3, which is equal to 2x. And then we have negative 12 plus 4 would be equal to negative 8. So now we've walked through those, and that one was more straightforward because it has everything perfectly lined up. So now if I wanted to do part B, that is g plus f of x. And you can see that they don't have everything that's the same. So if we write this out, we'll write out our f first as x cubed plus 3x squared minus 2x plus 10. We have f there, so if we wanted to write g out right underneath it, we'll just line up the like terms, the 2x and the minus 1 at the bottom here, and we can write out our answer as, well, we can just bring down these first two. There's nothing happening to those, and they don't have any like terms in the second function. So I know I'm going to have x cubed plus 3x squared, but now we have negative 2 plus 2x, which is equal to just 0. And we have 10 plus negative 1 is equal to 9. And if I were to rewrite this one more time right underneath it, well, I have my x cubed, and this 0 would just go away. So my actual answer for part B would end up being equal to x cubed plus 3x squared. That's 3x squared plus 9. And then finally, we have f of x plus k of x. And we're going to kind of do that same lining up just for these first problems to make sure we're all on the same page. So f first, x cubed plus 3x squared minus 2x plus 10. And then k only has x squared down to the constant, the number. So we can write negative x squared minus 3x plus 4. And we can just put all those together to get our answer of x cubed. And then we have 3 plus negative 1 is equal to 2x squared. And negative 2 plus negative 3 is negative 5x. And 10 plus 4 is equal to 14. That's a 14 right there. I'm going to cut off a little bit by my picture. So that's right there a lot of our good examples of addition. In these next in this next problem, we are doing a sum of a couple different graph problems in this next, and we're seeing, well, when we're talking about graphing and adding polynomials, if we're looking at two line functions, which are known as linear, if we add two linear polynomials expressions together, or functions together, is the answer we get going to be the same thing? So the first thing I might want to do is draw in a little xy axis on my graph here, just so I can know where I'm placing some points. So we'll do that first, and we'll change colors for plotting points. So keep in mind now that we're looking at like the graph of L of x and M of x. So L of x and M of x are both y values. So what we're really looking to do is at each x value, we're going to add the y part of the coordinates of the two functions. For instance, at 0, we have 1 and 2, or 2 and 1. So that means we're at 0, we're going to plot a point at 3. So we got our point at 3 right there. And then we're going to kind of go maybe by 2s, and once we have enough points, we'll see if we can draw a line. So at 2, I'm at 4 over here, and -1. So 4 on the y-axis plus -1 on the y-axis would be 3. So I have 3 right over here. And if we keep going out to 4, right here, we have 6. And we have -3. So 6 plus -3 would be equal to 3. So it's looking like we have a flat line. So let's just make sure we're doing it right. So let's look at -2. We're at 0 over here. And at -2, we're at 3. So it turns out when you add these two together, they're going to be equal to a flat line. If you add these two functions together, it just equals 3. So basically our answer is this, and really whole thing ends up equaling to 3. And that's the y values, like I said earlier. So let's move to another problem like this. So now we have a linear equation, linear polynomial, and this is a parabola, which we'll learn about in later chapters, and you might remember from prior years. So let's look at drawing in an xy axis first on our graph. We got our y-axis, and we have our x-axis, and we'll change colors for our points. So at 0, good place to start. We're at 1 and -2. So 1 plus -2 is equal to -1. So at 0, we're at -1, first point. So let's go left 2. So at -2, we're at 3. And at -2, we are at what looks like a 2. So we have 3 and +2 would equal to 5. So we're going over to 2 and up 1, 2, 3, 4, 5. Let's go the other direction. At +2, we have a -1, and we have a 2 here. So 2 and -1 is equal to 1. And so we have a point there. So based on those 3 points, we don't know exactly what it's going to look like yet. So let's add a couple more points to see if we can graph it a little bit more accurately. So at -1 on the x-axis in our first graph, we're up at 2. At -1 here, we're down at -1. So 2 plus -1 is equal to 1. So we can place a point right there. So let's keep marking some points. So at +1, I'm at 0, and at +1, I'm at -1 here. So that means I'm at -1. And it looks like we're starting to form a parabola shape on this right side. So let's kind of go out to kind of find a mirror 1 for this point to +3 on the x-axis. So here I'm at -2, and positive 3, I'm up here at 7. 7 and negative 2 would make 5, and that lines up here. So we can draw our parabola, and we'll see if I can draw this with my mouse. Almost perfect. And so we have a parabola here where we had linear plus quadratic equals quadratic. So that is very commonly what's going to happen. If we have an x squared in one and you add something that's just linear, that x squared is not going to go anywhere. Moving on. So now we have another example of linear and cubic, which is what this one is going to be, which we'll explore a little bit more of in Math 3 next semester. And so if I want to kind of start marking points, it's going to be a little bit harder. So we're going to mark points on this cubic one. So we have at 2, x equals 2, we're at 0. And at x equals 2, we're at 4. So we're going to mark basically 4 plus 0. Yeah, 4 plus 0. And so 4 plus, we got to draw it on our y-axis first, sorry. So we can do that now. All right, so now so we said at 2, x equals 2, we have 4 plus 0 is 4, 2, 3, 4. And we have at x equals 3, we have 1 and 5 would make 6. 4, 5, 6. And we have at positive 1 on the x-axis right here, we have negative 1 and 3 would make 2. And so we can kind of mark that down. And if you were to kind of get those in-between points, we don't have a lot of other points here, so we can go up to 4, but that is going to kind of take us off our graph. It turns out that it's going to end up looking kind of like that right there. So we can kind of move into our next slide.